In our lesson today, we're going to develop a good understanding of the distributive property, and we're going to use some of these tiles that you see over here, and I've got them drawn on your paper to help us really understand what's going on when we're working with the distributive property. Okay? I have these green tiles here, these long rectangles, which are represented by these pictures on your paper. These are going to represent your variables. Okay, so if you want to go ahead and draw that or label that on your picture, you can go ahead. That means a variable. Okay? These little squares, these are going to represent my constants. Okay, so I'm going to go ahead and call this a constant on my picture. Okay, and what I have here, I'm asking this question. It says, what does 2 times x plus 3 mean? Okay, and so this is a multiplication problem. If we remember multiplication, multiplication represents repeated addition. And so this means I'm going to add 2 groups. I'm going to add 2 groups of x plus 3. Add 2 groups of x plus 3. Okay, well, to show x plus 3, I'm going to use one of these rectangles, which is my x, and 3 of these squares. One square represents 1, and so 3 squares is going to represent a positive 3. So this is my x, this is my positive 3, my constant. And since I need 2 groups of that, I have my other group over here. Here's my other x and my other group of positive 3. Okay, so this means I need to add 2 groups of x plus 3. And so if I were to add these groups together, I can only combine things that are similar to each other. So I would take my variables and add them together, and then I would take my constants and add them together. Okay, and so now looking at my variables here, I have 2 variables, so that's going to represent 2 x's. And then I have 6 of these squares. Remember that these are my constants. This is going to represent my positive 6. Okay, so 2 groups of x plus 3, when I add them together, that's going to give me 2 x's plus 6 as my constant. Okay, and so I can see here that if I were to take this 2 and multiply it by each of these terms on the inside, that in fact is going to give me this 2x plus 6. So I can show that. 2 times x is the same as 1x plus 2 times that number 3. Okay, 2 times 1x is 2x, 2 times 3 is positive 6, and that's how I end up with this expression here, 2 times x plus 6. And what I've just done here, I've shown it right here in this step. This is actually where the distributive property happened. The number that's on the outside of the parentheses multiplies both of the numbers that are inside of the parentheses. That's called distributing. I'm distributing the 2 to the x, and I'm distributing the 2 to the 3. And then I use my multiplication to come up with the new terms, and so that's equivalent to 2x plus 6. In our next example, we're being asked, what does 3 times 2x minus 1 mean? And again, this is a multiplication problem, and multiplication represents repeated addition. And so this is going to mean to add 3 groups this time. Okay, this number outside represents my number of groups. Add 3 groups of 2x minus 1. I'm going to add 3 groups of 2x minus 1. And I've drawn the picture on your paper here, but I also wanted to show you with the tiles what that would look like. I've got my 2 rectangles here, which again are going to represent my variables. And then I've got my square, which is going to represent my negative 1. Notice that the color this time is a red. Okay, last time they were yellow. Yellow is going to represent a positive 1, but since I can see right here that I'm supposed to have a negative 1, and I can see right here in the problem that that's a negative 1 if I cover that up, now I'm going to have a red tile to show that. So what I want to do, I want to add these 3 groups together, and again, I can only combine terms that are similar to each other. So what I'm going to do, I'm going to get my variable terms together, and I'm going to get my constants together. Okay, and so now when I add up all my variable terms, I have 2, 4, 6 variables, so this is going to be a 6x. And I have 3 squares, but they're red this time, so this is going to represent the number negative 3. So I've got my 6x's and a negative 3, so I'm going to have 6x minus 3, when I combine all of my similar terms together. And again, I can show this using the distributive property. The number that's on the outside of the parentheses is going to multiply each of the terms on the inside of the parentheses. So this is going to be 3 times 2x. Okay, and then I'm going to write plus 3, because this 3 is positive, times negative 1. That's a negative 1 right there. Okay, so 3 times 2x is going to give me my 6x. And positive 3 times negative 1, they're different signs, so I know my answer will be a negative number. That's going to give me my negative 3. So I'm going to write 6x minus 3, which matches what I got when I combined my tiles. In my third example, I'm asking, what does 3 times negative 2x plus 1 mean? Okay, so again, it means that I have 3 groups. I'm going to add 3 equal groups of negative 2x plus 1. And again, here's what the tiles would look like on your paper. Here's what the actual tiles look like. And this time, notice that the 2x, the variable term, is negative. And I showed that in the picture here. When I'm using the tiles, that means that these tiles have to be red tiles. Red tiles represent negative. Before, if you remember, they were green, but now since they need to be negative, I need to make them red. So I've got my negative 2x right here with my variable tiles. And again, I've got my positive 1, so it's a yellow tile again to represent a positive 1. And I've got 3 groups of that. Here's my first group, here's my second group, here's my third group. And again, I want to add those groups together. So I'm going to combine my terms that are similar to each other. So I'm going to get my variables together. I'm going to get my constants together. All right, and now when I look at this picture, I have 2, 4, 6 variables here. But since they're all red, remember that represents a negative. So that's going to be a negative 6x. And then I've got my 3 yellow squares here. Yellow is positive, so this is going to represent a positive 3. So when I add 3 groups of negative 2x plus 1, I get negative 6x plus 3. And once again, I can show that with the distributive property. This 3 is going to multiply both terms on the inside. So 3 times negative 2x plus 3 times the positive 1. 3 times negative 2x is negative 6x. 3 times 1 is equal to 3. And that matches the expression that we got when we combined our similar terms with the tiles. In the fourth example, I'm asking, what does 2 times 3x minus 4 mean? So again, this number out here represents the number of groups, so it means 2 equal groups of, and in this case, it's 3x minus 4 that we would be adding together. 2 equal groups of 3x minus 4. Notice I didn't give you the picture this time. I want you to draw the picture of what 2 groups of 3x minus 4 would look like. Okay, so I'm going to start with my variable terms here. The variable term is a 3x. And remember, if you look back at our examples here, the variables were those rectangles. And so what I'm going to do to draw 3 x's, I'm going to draw 3 rectangles. So I'm just going to draw one big giant rectangle first, and then I'm going to split it into 3 groups there. And then to show that these are positive, I'm going to put a plus sign inside. So that's how we would draw 3x. Okay, then I need to draw the minus 4 or the negative 4. And the constants, remember, were our squares. So I'm going to need to have 4 squares. 1, 2, 3, 4. And to show that they're going to be a negative, I'm going to put that negative symbol on the inside. So that's how you would draw one group of 3x minus 4. But I need 2 groups of that. So I'm just going to draw this picture again. So I'm going to start by drawing my variable rectangles. I had 3 of them, and they were positive. And then I had my 4 squares, and those were all negatives. And so here's what 2 groups of 3x minus 4 looks like. If I combine my terms that are similar, all right, I'm going to combine my variable rectangles. I have 3 there and 3 there. That makes 6 of them, so I'm going to have 6 variables, or 6 x's. And then I have 4 negative squares here, 4 negative squares here. That makes a total of 8 negative squares, so that's going to be my constant, negative 8. So when I combine 2 groups of 3x minus 4, I get 6x minus 8. I can show that I would get the same thing by using the distributive property. So rewrite the expression 2 times 3x minus 4. And now this 2 is going to multiply each term on the inside. So 2 times 3x plus 2, because again, that's a positive 2, times negative 4. That 4 is negative. And now when I multiply 2 times 3x, I get 6x. 2 times negative 4, I get negative 8. And so I get 6x minus 8, which again matches what I got over here when I combine my similar tiles. In example 5, they are asking, what does 2 times 5 minus x mean? Well, again, you've got your number of groups, so it means 2 equal groups of, in this case, 5 minus x. 2 equal groups of 5 minus x. Now, this one looks a little bit different because notice I've got my constant in front and I've got my variable at the end. Okay, if you want to reverse that, you can. This would be the same as 2 groups of, and if I put my variable first, remember, cover that up, that's a negative x, which is the same as a negative 1x, negative 1x, and then that 5 is positive, so I can write plus 5. Okay, so that might help you understand it a little bit better. 5 minus 1x is the same as negative 1x plus 5. So I need to show 2 groups of that, so let me draw that. My variable term here is a negative, and I need 1 of them, so I'm just going to draw 1 rectangle. And I'm going to make it negative. And now I need 5 constants, 5 squares. So 1, 2, 3, 4, and 5. And they're positive, so I'm going to put plus signs inside. There's 1 group. I'm going to draw another group of that. There's my 1 negative variable, and I need 1, 2, 3, 4, 5 squares, and they were all positive. So there's my 2 groups of 5 minus x, or negative 1x plus 5, and now let's combine our similar terms. Okay, now here, down here, they've got the constant first, so I'm going to work with the constants first. I have 5 positives here, 5 positives here. That makes 10 positives. Okay, and then my variable terms, I have 1 negative here, 1 negative here. That's 2 negative variables, so minus 2x. So 2 groups of 5 minus x is the same as 10 minus 2x. And again, you can reverse that if you want to have your variable terms first. That would be a negative 2x and then a positive 10. I can show that I would get the same thing using the distributive property. Rewrite the expression 2 times 5 minus x. The 2 is going to multiply each term, so 2 times 5 plus 2 times the negative 1x. Remember, that's a negative 1x right there. 2 times 5 gives me 10. 2 times negative 1x gives me negative 2x. And again, if you want to have your variable term out front, we could put the negative 2x first, and then the positive 10 constant at the end, and that's going to match what we got over here when we combined our tiles. For example 6 and example 7, I'm going to have you practice these. So I want you to fill in your blanks, tell me what the meaning of this expression is, and then you're going to draw your tiles, okay, and then you're going to show me with the distributive property. Okay, show me with the distributive property how you could come up with the same expression that you would get as when you use your tiles. Do that for question 6 and for question 7. Fill in those blanks, draw the tiles, show me with the distributive property.